chapter, in this video, I will explain on how to refer to the graph, chart, or table, okay, for a heat exchanger. So now we have two different methods in heat exchanger analysis. First is lmtd, and second is effectiveness and Q method. Both of these methods have their own graphs, okay, or tables. So this is the tables for lmtd method. In this table, you have to provide with the value of P, where this P is T2 minus T1 for the tube side, and then over T1, capital letter T1, is for shell side minus T1 for the tube side. And then after that, you have to calculate what is the value of R, okay, by using the equation here. This chart will be provided to you in your appendix, final exam appendix, and you will see that this equation is stated in this chart. So after you determine the value of P, you have to calculate what is the value of R. So after that, you will refer to this figure. But before that, you have to remember that you have to select, because here we have different types of graph or different plots, graph plots or graph chart plots here. So you have to take a look in your question types of heat exchanger. Okay, for example, one shell pass and two tube passes. So you are only referred to the first chart here. And if your types of heat exchanger is 2 shell passes and 4 tube passes, then you have to refer to the next number B. Okay, you have to refer chart B. And if you have mixed flow and unmixed flow, then you have to refer to this last two chart here is for the cross flow. This last two chart is for cross flow. Okay, cross flow. For example, radiator, that is cross flow. And under cross flow, we know that we have two different types of cross flow. Okay, one is unmixed and another one is mixed flow. So you have to select. So for C is unmixed flow, and whereas for D is for unmixed. Sorry, unmixed is for the tubes, and then mixed is for shell side. So this is mixed flow. So mixed flow, and then here is for unmixed. Okay, under the cross flow heat exchanger. Okay, so how to refer to this figure or to this chart? I enlarge one of this chart. Okay, I enlarge chart A. So we have P value here and then R value. So you have to determine the value of P and R, substituting the value of T. Here T, uppercase T, okay, is for shell. Okay, shell, and smaller case T is for tube. Okay, you may refer to this figure. T is for shell side and T here is for tube side. So one shell pass and two tube passes, for example. So let's say your value of P is 0.5 here. So you have to draw a line, straight line. Sorry, my line is not straight. I believe that if you are using your ruler, then you will get this straight line. So draw straight line up to 1. Okay, now you already have P value, which is 0.5. Then you have to calculate R. For example, your R is 0.6. So this represent value of R. So your R is 0.6. Then you have to take a look at the line that represents 0.6, R for 0.6. So you take a look at this line, and then it intercept at this point here, intercept, point of interception. So this point of interception, you have to draw line, drag your line, go to this correction factor axis, okay? And then after that, you determine what is the value of F. Okay, so that is how you determine the value of correction factor. What if your R value is in the middle? For example, here we have 1 and 0.8. So your value is about 0.9, for example. How can you determine, or how can you predict the point of interception between a point of interception for 0.9? So what you need to do is you have to tick here and another one here. So I change the color first. Green. So tick here. Here is the interception for 0.8, okay? And here is the interception for 1.0. So bring your rulers and find what is the length of this from point here to here. So let's say it's 1 centimeter. This is my method, okay? I use the method of interpolation to determine what is the point of interception for 0.9. So now 0.8 and 1, 0.8 is the lowest, so I will put it here. 0.8 will be my 0 centimeter, and I want to find what is 0.9 x centimeter, and then for 1.0 I have 1 centimeter. So from here you have to find what is the point of interception. So if you already get x, for example, you get x is 0.2, okay, for example. So you have to calculate from here, because your starting point is 0.8, and find 0.2, tick, that is the okay, this is your point. You calculate from here and then try to find 0.2 and tick under the same line, 0.5, P lines 0.5, and tick, drag to this correction factor axis. So you will get the value of F. And then next is figure 1127. This figure is actually for effectiveness NTU method. As you can see in this figure, we have effectiveness here. And each of these graphs represent different types of heat exchanger. So you have to take a look at the naming of this graph, chart. So what you need to do here is you have to calculate what is the NTU by using this equation. NTU is equivalent to ASU over C minimum. And then after you determine the NTU value, or you already calculate the NTU, then you have to calculate what is C, smaller case C, where C is C minimum over C maximum. So you have to calculate this and refer to this C value, okay? The line of this graph. For example, your NTU is 2. So you for a parallel flow heat exchanger, double part parallel flow heat exchanger. So you drag, your NTU is 2, and then you draw a straight line up to 100, and then your C is 0.5. So take a look at the point of intersection, then you have to drag to this and find what is the effectiveness. That is how you find the effectiveness for figure 1127. If you don't want to see this figure, for example, I don't want to see this figure, it's okay. You have another option where you can find your effectiveness by using table. Because this table, after you substitute the value and you plot, you will get this chart. So if you do not want to refer to this figure, it's okay. You may refer to this table 11.4. So in table 11.4, you have to determine the heat exchanger type. For example, you have parallel flow. Okay, here we have parallel flow. Now, what we have to do is we have to calculate what is the NTU. So the NTU equation is here, UAS over C minimum. And then you have to calculate what is C by using C minimum over C maximum, and then substitute into this equation, find what is the effectiveness. So this equation, this table only can be applicable for if you know, or if your NTU can be calculated or NTU is known. Okay? So what if sometimes you have to calculate, normally table 11.4 uses to find what is the effectiveness. Normally the question asks you to find what is the actual heat transfer rate for that system, and you have to calculate what is the effectiveness. Sometimes the question asks you about some, this is an example, and the question might behave differently. Okay, sometimes the question might ask you about what is the area or what is the length, and the NTU is not been given in your question. Okay, what you have to do is you have to calculate what is the NTU, but at the same time you can actually calculate what is the epsilon, because epsilon equation is Q actual heat transfer rate over maximum heat transfer rate. You can find what is the epsilon. So from epsilon, we can actually get the NTU values. How? So by using table 11.5. From this table, you already know about the value of effectiveness here. So we have the effectiveness. So you have to calculate what is C and substitute into this and effectiveness into this and find what is the NTU. So from NTU, you can actually find area, for example, or a question asks you to find what is the length of the heat exchanger. So after you transfer into this equation and substitute into this, and you may find what is the length of the heat exchanger. Okay, that is all tables and graphs used in chapter 4, heat exchanger. So after this, we take a look at the example to make you much more understand about what is NTU method and log mean temperature difference. How to solve the problems related to both of these methods. Okay, thank you.